So hello and welcome to this presentation. My name is Gijs Louwers and I'm going to talk to you about the topic designing with dynamic light textures and lighting designers. I would first like to introduce you to our team. And our team consists of Professor Sylvia Pont, Martin Havranek, and Mitchel van Zuijlen, and myself, Gijs Louwers. We represent the TU Delft and the Dynamic Lighting Lab in this. And first, I want to introduce you to a very important concept, which is called atmosphere perception, which is defined as the affective evaluation of the personality of the space. So this is a very cryptic and abstract term. And I will explain this further with a example. So if we consider this room, and we could say actually that it has a certain personality, right? It has, yeah, kind of a vibe to it. And this vibe consists of several elements, so that contribute and drive the personality of this space. One of which is the objects in the room. Another element of this personality is the architectural elements. And the third and most important one is the lighting conditions and the light sources itself. So these three elements, they drive the personality of the space. And the way in which we interpret this personality of the space and evaluate it, most importantly, is called the perceived atmosphere. So bearing this in mind, and now that we have an idea of what perceived atmosphere actually is, we look at previously done research. So a group of researchers in Eindhoven, at the TU Eindhoven, wrote a paper called Atmosphere Metrics. And what they actually found in this research was that there are 4 underlying dimensions in atmosphere perception, which is called the sense of coziness, the sense of liveliness, the sense of tenseness, and the sense of detachedness of atmosphere. And perhaps the most significant finding of their study was that static lighting conditions can actually change your perception of atmosphere. So in the same space, if you would change the brightness levels or the color temperature of the light, it could result in a different atmosphere. The goal of our study was to expand upon this research and to investigate how an atmosphere impacted by dynamic light conditions can be described. So in order to do this, we first needed to kind of define dynamic light. So dynamic light conditions. So we called these dynamic light textures. And we drafted a set of characteristics to describe these. The first characteristic that we found, or that we drafted, was the organization of shapes. And in a pattern, this can be done in a deterministic way, which means that it seems to follow a set of rules. And it can be done in a very chaotic way. The second characteristic that we found was that of form. So form was defined by us as the style of the different shapes. So it can be either geometrically styled or organically styled. The third characteristic that we defined was the characteristic of contrast. So color, brightness, or sharpness contrast. And the fourth characteristic was the one of dynamics. So a slow rate of change versus a high rate of change of all of the previously mentioned characteristics. So now that we have a grip of what we actually mean with dynamic light textures, we could ask ourselves the question of our research. So what is the influence of dynamic light textures on the perception of atmosphere? Of course, this is very broad. So we wanted to divide this up in a couple of smaller sub-questions. The first sub-question, in order to actually get a first feeling of how people describe the atmosphere influenced by dynamic light conditions, was which words do people use to describe their perception of a dynamic atmosphere. The second sub-question was, what underlying variables influence the perception of dynamic atmospheres? And our third sub-question, what impact do the characteristics of dynamic light textures have on atmosphere perception? So in order to do this, we generated 13 different stimuli. And they're shown on screen right now. 12 of them are shown. These are all programmed and based on naturally occurring phenomena. And these were our input stimuli. So we set up 2 experiments, and I will explain them in more detail in a second. But for both of the experiments, we used 13 stimuli, and for the first experiment, we used 10 participants. And we asked participants in the first experiment, generate at least 1 word per atmosphere created by the dynamic light textures. And in the second experiment, we wanted to use the words generated by the first experiment and ask participants to rate these words on their applicability to the stimulus shown, or the atmosphere created, actually. So this is what that would look like. You can see this participant is in a chair, and she's currently in the atmosphere created, and you can see that there's kind of an overlap between the architectural elements and the texture itself, and there's another light source as well, to not have the texture as the only light source in the room. And she's actually naming words that she associates with the created atmosphere right now. So this is a schematic representation of this. So you can see that the participant was seated at A and the light source at B, you can see, and there's the projected texture on the wall and architectural elements. So what we actually found was that people use roughly corresponding, and they use kind of the same words when they're describing the atmospheres. So obviously we found a lot of words, so we had to cut out the ones that were mentioned only once, and we still ended up with 160 words or something that were actually significant and mentioned frequently enough. So what we then did, we did a clustering session with a couple of researchers. And we found that there were several words that had corresponding meanings, and they were actually strongly related to each other. So we took these together, like powerful and strong in this example. And we picked the one that was mentioned most frequently as the representative of this. In doing so, we found 40 words, which are indicated by the little arrows that you can see right here. And this actually formed our vocabulary for our second experiment. So in our second experiment, of which you can see a photo right here, our participant will be seated in the same kind of environment. We moved the lamp a little bit because else the participant couldn't see their questionnaire. But we gave these participants a questionnaire on which they would write down the applicability of the words that were generated in the first experiment to the stimuli shown. So that would look something like this. You would have the list of 40 words per texture or atmosphere created, and they would rate it on a 7-point Likert scale on the applicability. So for instance, they would find frustrating very applicable to the texture, and pleasant they would find more or less not applicable. So accordingly, they would fill out the entire form, and already you can see some kind of pattern emerging here. You can see that frustrating and confusing are kind of, yeah, they correspond to this, they are taken together a little bit, and then structured is not applicable at all. So we already see some opposites and some sort of construct appearing in this. What we did after this, because we had 13 stimuli, we had 16 participants in the second experiment, we had 40 entries each, which roughly comes down to 8,300 entries, which is a vast amount of data, obviously. We had to find a way to make sense of all this. So The analysis that we used is called a PCA, a principal component analysis, which is a statistical analysis for visualizing and finding key components. And in order to explain better what this actually translates to, I will give you an example. And the key element of this is, how do we interpret these results? So we plotted all of the words and the values that were and the responses given by the participants in a system of axes. So this we call the dimensions. Dimension 1 is the horizontal axis, and dimension 2 the vertical one. And on the right side, you can see that there's words like intimidating, scary, unpleasant, frustrating, dangerous, dirty. They roughly correspond to a sense of suspense, right? A sense of suspense more in the negative way, kind of. On the left side, we can see evolving, captivating, immersive, mysterious, alive, explorative, which is also kind of a sense of suspense, but more, I guess, in an interesting or positive way. So this we call the tenseness axis. We interpreted this relationship between all of these words, and we call it the tenseness axis. The same thing we did for the vertical axis, which we call the liveliness axis. And we found, for instance, in the positive values of that, we found structured, and in the lower ones, we found chaotic. We also found a third dimension, which we call the sense of detachment, where we can find kind of a business-like, serious, structured sense of atmosphere in the lower regions, and in the higher regions we find free, open, playful. So it's a sense of business-like versus free or playful. And this is the liveliness versus detachment mapped. And I'm showing you this because we can find a feature space, as we call it right now, if we intersect all of these planes together. So we find the tenseness versus liveliness, we find the tenseness versus detachment, and the liveliness versus detachment. And most interestingly, or most importantly, what we could find right now is that if we want to map our textures that we use for this experiment, we can actually do that in this feature space. So that's exactly what we did. We took the axis that we generated earlier, and we plotted all of our stimuli in this grid. And you can see it immediately is clear that there's no stimuli found on the right side of the tenseness axis, but that's mainly due to our stimuli. We tried to take a sample of stimuli that were most diverse, but apparently we didn't make it tense enough. But if we look at these, at the extremes of these stimuli, for instance, the top one, which is highly deterministic, high brilliance, low rate of change, as you can see right here, versus the lower one, which is chaotic, low brilliance, and a high rate of change. We can see that the characteristics that we earlier drafted are actually of impact on where we can find these textures on the inner system of axes. So on the right side of this grid, we can find a organic or high color temperature and a high rate of change atmosphere created by this texture. And on the left side, we can find a geometric, low color temperature, low rate of change texture. So we can see that there's a strong relationship between on these axes created by the characteristics. So answering our question, what is the influence of dynamic light textures on the perception of atmosphere? There's actually several answers that we can give to this, our conclusions of our research. So in our research, we found 3 dimensions. We found tenseness, the sense of tenseness of an atmosphere, the sense of liveliness, the sense of detachment. And in the research done into the static light conditions and their impact on atmosphere, the research group in Eindhoven found that there are 4 dimensions. So the dimension that's missing in our construct is coziness, and that's actually quite logical, because dynamic light textures are not, or atmospheres created by dynamic light textures are not really rated on their coziness. They're more rated on their interestingness and our captivatingness. We also found that both dynamic and static conditions impact atmosphere perception, combining these 2 researches together. And we found, based on what I have just shown you, that dynamic light characteristics, as we drafted them, impact the sense of tenseness, liveliness, and detachment of an atmosphere. So, related to this, we can say that organization, so the sense of deterministic or chaotic organization, influences the liveliness, or where a texture is found on the liveliness scale. The form influences the tenseness. Sharpness and brightness contrast influence detachment. And the dynamics influence all of the above. So, what have we actually learned? First, we learned that atmosphere perception is defined as the effective evaluation of a space. And we have found that both static as well as dynamic lighting conditions have an impact on atmosphere perception. And perhaps most importantly and most useful, is that we found that a way of communicating between clients and designers when they're designing with dynamic light textures. So for instance, if a designer is asked by a client to come up with a certain design that's sort of tense or exciting or captivating, the designer can then use our interpretation of the axis and the organization of, or their characteristics of the intended dynamic light texture to come up with a design. So it's a way of communicating and kind of a lingo to be able to actually draft these designs. For more information, obviously, there's a lot of research went into this, and we have published this at the TU Delft repository. And you can there download this entire research, Designing with Dynamic Light Textures, Enlightening Designers, by Gijs, Louwers, Sylvia, Pont, Havranek, and Mitchel van Zuijlen, in collaboration with TU Delft. And this includes download links to the stimuli video files that we used. I would very much like to thank LPS for hosting me here, and I would very much like to see everyone in the, hopefully, 2021, when everything's okay again. Thank you very much for your attention.